Okay, let f of c of a complex number equal to u of x and y plus ib x and y be an analytic function if u of x and y is given by the following functions. In this case, we're going to try to solve the part b, e to the y sine of x. So in order to find, so first what we need is step number 1, find the partial derivative of u of x and y equal to e to the y sine of x. Therefore, partial derivative in terms of x is going to be equal to e to the y cosine of x. As well, we can find the partial derivative of y, double y, equal to e to the y sine of x. Since e to the y is an exponential, they are the same, the derivative is the same. Okay, so we have this. Then the second step, step number 2, verify that u is an harmonic function. So in order to verify that u is an harmonic function, we need to take the second partial derivative and the addition. So then once we have already taken the second partial derivative of u of x and the partial derivative of u of y, the double partial derivative of u in terms of y, so when we add those terms, the second partial derivative of u of x and the second partial derivative of u of y is going to be equal to 0. Therefore, we need to take the second partial derivative of u of x and y. So therefore, let's see. U of x, the second partial derivative of u of x is going to be equal to negative e to the y sine of x, and the second partial derivative of u of y is going to be equal to e to the y cosine of x. So therefore, since it says that u to the x, or the second partial derivative of u of x plus the second partial derivative of y is going to be equal to 0. So in order to prove that there is an harmonic function, therefore, we know that here we have negative e to the y sine of x plus here look what I did here. I did a mistake in this section. The second partial derivative of u of y is still e to the y sine of x. I was taking the second partial derivative in terms of x. That was my mistake. So again, we need to take the second partial derivative in terms of y. And the second partial derivative in respect to y is going to be equal to e to the y sine of x. Okay, was a mistake. So therefore, if we add negative e to the I sine of x plus e to the y sine of x, the addition of those is gonna be equal to 0. And as we can see here, this one, they are the same, but just with opposite sign. Therefore, they cancel each other. So as a result, it means that yes, it is an harmonic function. A harmonic function. So the step number 3. There's also step number 3. So since we need to construct the imaginary part of our function, because at the beginning they just give us the real part of the function, but we need to construct the imaginary part of bx and y. So therefore we need to integrate, or we need to differentiate. Okay, we need to integrate in terms of y. So therefore, in order to construct the b of y, in order to construct the b of x and y, we need to integrate u of x, y with respect to, we need to integrate with respect to y. Therefore, because if we remember from complex number, we know that u of x is equal to by. It comes from the imaginary part. As well, u of y is equal to the negative of bx. Okay, since we are interested in get bx, the imaginary part, so we can integrate in terms of y in order to get our bx. So therefore, we can say that b of x and y is going to be equal to the integration of the partial derivative of u of x with respect to the y. And of course, it's going to give us plus constant terms in terms of x. So it's going to be equal to the integration of u of x. Since we have already taken the u of x was e to the y cosine of x plus, in terms of dy, plus c of x. It's going to be equal to e to the y is going to be the same. Since we know that, so with respect to y, it's going to be equal to e to the y cosine of x plus c of x. It's going to be equal to my b of x and y. Okay, we get this term. Okay. So now, the fourth step is going to be, we need to differentiate the left and the right side of the equation of with respect to x. So that then now what we have to do is gonna be equal to, since we mentioned this, in order to get my bx is gonna be equal to u of y. So the step number 4 is gonna be equal to my first partial my derivative is gonna be equal to, okay, differentiate the left and the right side of the equation of the bx and y in terms of x. In other words, we have this negative, taking from this part, we have u of y is equal to negative bx, right? Therefore, bx is going to be equal to negative u of y. That's right. So now, since we know what is equal to negative y is going to be equal to, it means that it is the partial derivative of u of y. It's going to be equal to the derivative in terms of x of the bx and y. In bx and y. Therefore, negative u of y. What was my partial derivative of u of y? My partial derivative of u of y is this. So then we can plug here with the difference that it is a negative e to the y sine of x equal to the partial the derivative in terms of x of bx and y we have already calculated is equal to e to the y cosine of x plus a constant in terms of x. Therefore, negative e to the y sine of x is going to be equal to, in terms of x, cosine, the derivative of cosine is going to be equal to the negative e to the y sine of x plus c prime, because it's the derivative of x. Now, if we realize here c prime of x is going to be equal to 0, because those terms is going to be equal to 0. And when we added those, it's equal to 0. Now we need to integrate okay. So step number 5. So we need to integrate c prime of x. Therefore, we have the integration of c prime of x is going to be equal to integration of, in terms of dx, it's going to be equal to the integration, since we have 0, of dx, and integration, we know that the integration of 0 in terms of dx is going to be equal to is going to be equal to 0, a constant plus a constant is going to be equal to 0, basically. It's going to be equal to 0. Okay, so therefore, the last step, hence, the harmonic conjugate of u is b, x, and y is going to be equal to bx and y is equal to e to the y cosine of x e to the y cosine of x plus cx. And what is cx? E to the y cosine of x, since we have already calculated cx, plus 0. In other words, bx and y is equal to e to the y cosine of x. And that will be the answer. Let's see if as we can see here, the answer is equal to e to the y cosine x plus c, where c is a constant. So our answer is correct. Because 0 is a constant, here c, sorry, I forgot something here. The integration of 0 dx is going to be a 0 plus a constant, some constant. Therefore, 0 plus another constant. So it's going to be 0 plus constant. 0 is, it doesn't matter, but it's going to be plus a constant. Now it makes sense that we get this answer. So therefore, if we want to write in the function of c, therefore the function of c is going to be equal to, we know is equal to the real part, u in terms of x and y, plus I b of x and y. Since the u is given, u of x and y was equal to, u of y is equal to e to the y sine of x, e to the y sine of x plus I bxy is going to be times e to the y cosine of x plus some constant. F of c. Therefore, we can do is equal to, we can say that it is equal to we can take and this is going to be our final answer. Of course, we can change, we can express in another forms. Let's see if it matches our answer. E to the y cosine of x plus See, or okay, they have already expressed in Euler forms or in polar forms. Let's see.